Hey everyone, good morning. I am Priyanshi Agrawal and welcome back to my YouTube channel. Now we are going to solve today's Leetcode daily challenge, which is sort colors. Okay, so let's see what is this question and how we can solve it. So in this question, you are given an array nums with n objects colored red, white or blue. And you need to sort them in place so that objects of the same color are adjacent with the colors in the order red, white and blue. Okay, so in this question you have been given with an array nums of size n which contains red, white and blue colored objects, and you need to sort the objects in the way that the objects of the same color should be adjacent and the order should be red, white and blue. And you have to sort them in place. In place means you need to make changes in the input data only. There should be no different output data. You have to make changes in the input only. And we will use the integers 0, 1 and 2 to represent the colors red, white and blue. So that is 0, 1 is white, blue is 2. You must solve this problem without using the library sort function. You can't just use sort nums.begin and nums.end. No, you can't use this. You have to sort this array such that all the colors should be adjacent, and you have to make the order something like this: red, white and blue, right? Okay, so can we just see that this is just a simple sorting question? It is just that we have given that we can't just use the sort function, but still we can use the merge sort something. There are a lot of sorting algorithms which you can use, merge, counting or any other sorting algorithm you can use. Okay, so let's say we use this merge sort. So the time complexity of merge sort is n log n, right? And its space complexity is also big O of n. Okay, first let's see the constraints. Yeah, constraints are very low. So n log n is also going to work. But like n log n doesn't seems good. So can we do this question in a little bit better complexity, as everyone knows sorting algorithm? So this is the very basic brute force approach for this question. You can apply any sorting algorithm and sort this array of 0, 1s and 2s. But can we do something else? Can we do this in a better time and space complexity? Okay, let's see. So let's see, you have been given with this array. What is 2, 0, 2, 1, 1, 0, right? Okay, so you need to sort it. So what can we do? Can we store the count of all 0, 1s and 2s in a map? Okay, let's say we create a map and let's say we store the count of 0 is 2, 1 is also 2 and 2 is also 2. Okay, so what we can do, we can now take the count of 0. Count of 0 is 2. So what we will do? We will insert 0 in the starting two places. Now we will take the count of 1, which is also 2. So we will insert 1 in the next two 1 places. Now we will take the count of 2 and we will simply insert 2 in the next two places. Is this our answer? Yes, 0, 1, 1, 2, 2. So in this way also we can get our answer. Okay, so let's see how we can code it. So see, here we have created a map which will store the count of all 0s and 1s and 2. So we will take the count of 0s and we will simply insert 0 in that places, and we will simply increment our I, and then we will take the count of 1, we will insert 1 in those number of places and then 2 in those number of places. So what will be the time and space complexity for this approach? So the time complexity will be this loop for n, and these 3 rows will contribute to n, right? Because here we are just iterating for 0s, then 1s, then 2s. So these all loops together will contribute to a n complexity. So its time complexity will be big O of 2 into n, and its space complexity will be, you might say that we are using a map, so its space complexity is n. No, map can be of up to maximum of 3 size only, because we have only 3 digits in the vector, right? So the space complexity will remain constant. Okay, this seems better than the merge sort time and space complexities, right? Yes, but here what we are doing these 2 iterations. This one iteration for getting the count of all the numbers, and then this another iteration for updating our nums. This seems quite good, no issues in that. But let's read the question further. This is a follow-up thing, like could you come up with a one pass algorithm using only constant extra space? Like this is a two pass algorithm, this one pass and then this another pass. This time and space complexity seems quite good enough, but like in the interviews also you can be asked that can you come up with some solution which contains only one pass. So yeah, let's see if we can come up with that solution. So there is one algorithm called Dutch national flag algorithm, which is the most optimal algorithm for this question. This might not be an intuitive one, like if you are going to understand it for the first time, then this might not seems to be that much intuitive. But yeah, if you will read this algorithm once, if you will understand it once, then you will be able to relate to it, you will be able to understand the logic behind it. So yeah, then you will be able to implement this algorithm in other places as well. So yeah, let's see what is this algorithm and how is this the most optimal algorithm for this question. So let's say we have some array of 0, 1s and 2s in which we need to sort. So let's say for this question, our row will be pointing to the starting of ones, see, let's say, and mid will be pointing to the end of ones, let's say here, not the next element to the end of ones, and your high is pointing to the start of one element before the start of two, before twos, let's say. Okay, so this is some middle state of a test case. So let's see, take our test case. What was that? 2021110. Okay, so let's take this test case 2021110. Initially our low will be pointing to this, our mid will be pointing to this, and our high will be pointing to n-1. Okay, so what we will do, we will check our mid element. What is our mid element? Right now it is 2. Okay, so let's start writing the conditions. If our mid element, this is not just mid, this is the element. If our mid is equals to 2, so what we will do? Okay, let's try understanding it from this. If our mid element is 2, then what we will do? We will swap our mid element with the high element, because we want to arrange all the 2's in the end, and our high is pointing to just one element before the starting of 2's. So if our middle element is 2, then what we will do? We will make this element swap with this element, right? And now our high will get decremented because it is pointing to just one element before the 2's. And is there any effect on the middle element? No, because it can be 0, 1 or something. So we can't make any changes to the middle pointer. So if our middle element is 2, then we will swap it with the high element, and our high pointer will get decremented. Okay, so let's see. So if our middle is 2, then what we will do? We will swap mid comma high, and our high will get decremented. Okay, so let's swap them. So now 1 is here, sorry, 0 is here, 2 is here, and now high is pointing to this position. Okay, cool. Now let's again check what our middle pointer is pointing to. Now our middle pointer is pointing to 0. Okay, so let's see what happens if our mid pointer is pointing to 0. So let's say if it is pointing to 0, then what we want to do? We want to swap it with the element at which low pointer is pointing, because low pointer is the pointer which is just after the ending of 0. So that's where we want to swap it with this one. Now this will come here, right? So what we'll have, sorry, 0 is here. So what we want to do? Obviously we want to increment our low pointer, because it should be pointing to the next element, to zeros. And what will happen to the mid pointer? Will it also get incremented? Yes, because mid pointer was also pointing to the next element to the ending of 1's. So now we have swapped it with the element 1. So now the mid pointer will also get incremented. in the case when mid is pointing to 0. Okay, so let's increment it. So let's say here, if it is pointing to 0, then it will get swapped with low pointer. So let's say, let me write the condition as well. Else if mid is equals to 0, then what we will do? We will swap mid and low will get incremented and mid will also get incremented. So what will happen in this case? Low and mid are pointing to the same position. It's just they both will get incremented. Now low is pointing here and mid is pointing here. Okay, again now mid is pointing to 0. So what will happen? They get swapped and now low will get incremented, mid will get incremented. Now mid is pointing to the 2. So what will happen? Mid and high will get swapped. So now 1 will come here, 2 will come here, right? Now what we will do? We will decrement the high pointer. Now high is pointing to this position, right? Okay, now again we will check what our mid is pointing to. Now our mid is pointing to 1. So let's see what will happen if our mid is pointing to 1. So if our mid is pointing to 1, then what we need to do? Let's say, so mid is pointing to the next element, to the ending of 1s. So if mid is pointing to 1, then what we need to do? We just need to increment mid and do nothing else. We don't need to do any kind of swapping or anything. We just need to increment the mid pointer. So right now mid is pointing to 1. So we will increment our mid pointer. Now our mid pointer is pointing to here. Okay. Now we will check what our mid pointer is pointing. It is 1. So let's increment our mid pointer. Oh, now mid pointer has crossed the high pointer. So it means we have already came to the end of our iteration, because we have arranged all the 2's in the end, all the 1's in the middle and all the 0's in the starting. As you can see in this test case as well, like here it's 0, here it's also 0, here it is 1 and then 1 and then 2 and then 2. We have arranged all these elements, we have sorted all these elements in this way. So what's the basic logic behind this algorithm is that you need to remember these things. Like low should point to the start of 1s, mid should point to the next element to the end of 1s, high should point to the one element before the start of 2s. So if middle element is 0, then you will swap it with the low element, and as the low element is for sure 1, so what we will do? We will increment low and mid, both of them. If mid is pointing to 2, then we will swap it with the high pointer and we will decrement the high pointer, but we will not increment the mid pointer because we don't know whether it was 0 or 1. So that's why we will not increment the mid pointer. And if mid is 1, then we will simply increment the mid pointer, because mid was pointing to the next element to the end of 1s. So that's why we will increment the mid pointer if it is pointing to 1. Okay, so I hope you get it. If you haven't, then take a pause and again try to think what I was saying, and again listen how I have explained this algorithm, then you will surely get it. So let's see its code once. It is quite similar. So we will initialize low with 0, mid with 0 and high with n-1, and we will initiate a loop till mid is less than or equals to high, and if nums of mid is 0, then we will swap it with low, increment mid and low. If it is pointing to 1, we will increment 1. If it is pointing to 2, we will swap it with high and we will increment high. So what will be the time and space complexity for this? Its time complexity will be go of n and its space complexity will be go of 1, as we have not used any extra space. So yeah, that's all for this question. I hope you get it, but if you still have any doubts, then you can post in the comment section. I will surely try to answer them. Till then, bye guys, see you in the next video.